Hi there. We're all using tools like ChatGPT these days, right? Well, today, we're going to pop the hood and see what's actually making that whole AI boom tick. We're going to break it all down, piece by piece. And that's a really good question, because that one little letter, the T, that's the real star of the show. It stands for the technology that's at the heart of, well, everything. It's the big invention. Okay, so generative and pre-trained are definitely important. Generative just means it can create new stuff, and pre-trained means it's learned from a boatload of data. But transformer? That's the part that's the real game changer. It's this special kind of neural network that, honestly, changed everything. All right, so here's the plan for today. We're going to start with what's basically a simple guessing game, and then, step by step, we'll build our way up to those really complex back-and-forth conversations you can have with a chatbot. Okay, let's get into it. The very first thing we need to understand is the core job of a language model. And you might be surprised to hear that deep down, at its heart, it's actually doing something pretty simple.
So at its core, a transformer is just an incredibly fancy next word predictor. Now, predicting the next word, that's not a new idea. Way back, we had these things called n-grams, which would just look at, say, the last 2 or 3 words and make a simple guess. But a transformer, its one job is to do the same thing, but with this unbelievable understanding of context. It reads a whole chunk of text and then spits out a probability, a list of odds for literally every single word that could come next. And this simple process creates something we call the generative loop. It's super simple. Predict the odds, pick a word from that list, tack it onto the end of the sentence, and then just do it all over again with the new, slightly longer text. Every single thing you've ever seen in AI write, it was built just like this, one single word at a time. Okay, so how does a computer, a machine, even start to get what words mean? I mean, it can't read, not like you and I. The first thing it has to do is turn our language into the only thing it really understands, numbers. This is a super important step, and it's called word embedding. Basically, every single word the model knows gets its own unique vector, which is just a fancy way of saying a long list of numbers. The best way to think about it is like coordinates on a map, but a crazy, high-dimensional map of meaning. Every word has its own specific spot in this semantic space. And this is where it gets really wild. The relationships between words are actually captured mathematically. You can literally do math with concepts. So check this out. If you take the vector for king, subtract the vector for man, and then add the vector for woman, you end up almost exactly at the vector for queen. It's like magic. And it's not just for simple stuff like that. It works for all kinds of abstract ideas. The model figures out that the relationship, the direction and distance between Germany and Hitler is really similar to the one between Italy and Mussolini. It's learning the concept of a country and its wartime leader. And, on a much lighter note, it also learns things like Japan is to sushi what Germany is to bratwurst. It's building this massive, intricate web of how all these ideas connect to each other. All right, let's head into the engine room. So we've turned words into numbers, into these vectors. But now, for the main event, how does the transformer actually use these vectors to understand context? So you can picture the data flowing through this pipeline. Your text gets chopped up into little pieces called tokens. Those tokens get turned into our vectors, and then they get fed into a series of what are called transformer blocks. This is where the heavy lifting happens. The vectors go in, get refined and enriched, and then a final vector comes out the other end, ready to predict the next word. Inside these blocks, there's this two-step dance that just repeats over and over. First, there's the attention part. This is where all the word vectors basically talk to each other. They exchange information and figure out which other words in the sentence are most important for understanding their own meaning. Then, there's a part where each vector thinks for itself, sort of digesting all that new info it just got. And this cycle of talking and thinking, it happens again and again through many layers. And here's the payoff for all that work. A vector that starts out as just the word king, well, after it goes through all those blocks, it can be transformed to mean something way more specific, like a Scottish king who took the throne by murdering the previous one. You see, it literally soaks up all the context around it. So you might be sitting there thinking, okay, this prediction loop thing, it sounds a little too simple. How does that write a whole essay? And you know what? You'd be totally right. On its own, it's not enough. The secret sauce, the magic ingredient that makes it all work, is scale. Just immense, Mind-boggling scale.
And this is the whole key right here. Just look at the difference. If you take a smaller model, something like GPT-2, and let it run that prediction loop, it pretty quickly just goes off the rails and starts spouting nonsense. But if you take the exact same design, the same architecture, and just make it massively bigger, like GPT-3, all of a sudden you get a story that actually makes sense. It's the size that unlocks the magic.
So what are we talking about when we say scale? We're talking about this number, 175 billion. That's how many adjustable parameters, or weights, are inside GPT-3. Think of them like tiny little knobs that get tuned over and over again during training. And it's that staggering number of knobs that allows the model to capture all the crazy, subtle nuances of our language. This is what separates a toy from a tool.
Okay, so we've built this incredibly powerful next word predicting machine. But how do we get from that to the chatbot you talk to every day? Let's connect those last few dots.
The trick is actually kind of genius in its simplicity. You basically frame the whole conversation like a play script. Before you even type anything, there is a hidden instruction, a system prompt, that tells the model its character. You are a helpful AI assistant. Then your question gets added to the script, and the model's job is just to predict the AI assistant's next line. See? It's still just playing that same old next word prediction game. And we can even mess with the knobs to control how creative it gets. There's this setting called temperature. If you turn the temperature down low, the model plays it safe and always picks the most obvious, most likely next word. The result is pretty predictable. But if you crank the temperature up high, it starts to consider the weird, less likely words, which makes the output way more creative, more surprising, and yeah, sometimes just plain random. All right, let's just quickly recap the big ideas here. Number 1, Transformers are at their heart super-powered next word predictors. 2, they work by turning words into these special number lists called vectors. 3, they use attention so that all the words can talk to each other and understand the context. And finally, number 4, the thing that makes it all work is just massive, massive scale. So really, when you get right down to it, every single time you have a conversation with an AI like ChatGPT, what you're actually seeing is that simple little loop. Predict, pick, repeat. It's just happening over and over again at a speed and scale that is, frankly, hard to wrap your head around. And that leaves us with a pretty powerful, maybe even unsettling idea, that something that looks a lot like intelligence can just emerge from a really simple process, as long as you scale it up to an insane degree. And make no mistake, this is the technology that's going to reshape our world. It could transform our economy, maybe even reduce the need for us to work at all. But it also comes with some pretty serious dangers. What happens when humans are no longer the most efficient thinkers in the room? When we become obsolete? It leaves you with this one profound question to think about. See ya.